What we will learn today is very important. Okay, you know probably that I am a metabolic scientist. So in addition to being a professor, I am a scientist. And much of what I study is metabolic health. That's what I want you to learn. So the first thing I want you to learn is, what is metabolic health? One way of defining or understanding metabolic health is to understand the metabolic syndrome. The metabolic syndrome is several disorders that always tend to come together. It's when we have too much fat around the middle of our bodies, or when our blood pressure is too high, or when our blood glucose or blood sugar is too high, or when our blood lipids are wrong or unhealthy, something called dyslipidemia. When these start to come together, we call it the metabolic syndrome. And it is one of the most, if not the most common health disorder worldwide. Roughly half of all adults worldwide have the metabolic syndrome. And in the Middle East countries, it's even higher. In fact, some of the highest rates of metabolic syndrome are in the Middle East. So this message is very, very important. Now, I call this the metabolic syndrome. That's what most people call these problems. However, it used to be called the insulin resistance syndrome. As a scientist and a teacher, I like that term better, even though it doesn't quite sound as good. There's something that sounds so nice about saying metabolic, but insulin resistance syndrome is more accurate, because all of these problems are connected to one thing, namely insulin resistance. But there are many more problems that are connected to insulin resistance as well. Problems like heart disease, or certain cancers, or fatty liver disease, or diabetes, or obesity. They are all connected to insulin resistance. Also, different types of infertility. I think having a big family is the most important thing in the world. We need more babies. We need big families in the world. And that means men and women must have high fertility. But the most common forms of infertility in men and women are also connected to insulin resistance. And then even disorders of the brain, problems like migraine headaches or Alzheimer's disease, even something like depression. All of these things have in common where the brain starts to become insulin resistant and the brain is hungry and it doesn't work as well. Now you may be wondering, or I want you to wonder, do you have insulin resistance? Is this something you should worry about? Well, I am a professor, so sometimes I like to do a surprise quiz in my class. Here's a surprise quiz for you to think about, for yourself and for your friends. Do you or your friend have high blood pressure? Do you or your friend have a family member with type 2 diabetes or gestational diabetes? That's a diabetes that happens during pregnancy. Do you, if you're a woman, do you have PCOS? Or a man, do you have erectile dysfunction? These are the two most common forms of infertility that I mentioned earlier. Do you have fatty liver disease? Now, all of these are things that are happening in your body that you might not know. But this is one that you can see with your eyes because it happens on your body. You can look around the neck of your neck or your friend's neck. And if you see that they have rough patched skin, it's dark and it feels like a piece of paper that has been crinkled or pressed up, then that is evidence of insulin resistance. Also, these little bumps around the neck are also sign of insulin resistance. So if you answered yes to any question here, it's very possible that you have insulin resistance. But most people don't know. Most people who have insulin resistance don't know they have it. Now, I want you to understand what insulin resistance is. And just for the sake of time, this is kind of a long description. I want to just go right to this point here. There are two ways to understand insulin resistance. Insulin resistance is two problems wrapped up in one. The first is that some cells of the body aren't responding very well to insulin. The second part of insulin resistance is that within the entire body of the person, blood insulin levels are much, much higher than they were before. Insulin resistance always comes with high insulin levels. You cannot pull them apart. They are part of, it's two sides of one coin. Now, one of the most common problems with insulin resistance is high glucose and type 2 diabetes. However, it takes time. If we look at someone's blood glucose levels, it takes time for their blood glucose levels to start to go up. However, if we look at insulin levels will be high much, much sooner than the glucose levels will be high. And so I want to cut this into two different times. This first time is insulin resistance. And you'll notice that while insulin is elevated, blood glucose levels are not. This is very important because very often we only look at blood glucose levels, but we need to also look at insulin to understand insulin resistance. And then eventually the body becomes so resistant to insulin that the glucose levels start to climb. So now they have still high insulin, higher than it was before, high insulin and high glucose, and that is when they have type 2 diabetes. But where does insulin resistance start? It starts in the fat cells, and then it shares that insulin resistance with other tissues like the liver or the muscle. And then when the liver and the muscle become insulin resistant, the problem just continues to the brain, maybe causing depression, to the ovaries causing infertility, to the blood vessels causing high blood pressure, and many, many more tissues. But the most common cause of insulin resistance is when insulin is too high, then fat cells will get bigger and bigger and bigger. That's what I'm showing here. When insulin goes up, it's like fertilizer. It's like I'm sprinkling fertilizer on plants in my garden. Now all the plants are getting bigger. When insulin is high, it's like a fertilizer on your fat cells, and it makes the fat cells get bigger and bigger and bigger. And when the fat cells get too big, they become very insulin resistant, and they become pro-inflammatory. They increase inflammation. They become insulin resistant and inflamed, and then this is what is being spread throughout the body, making other parts of the body also become insulin resistant. Now, a moment ago, I said that having high insulin will feed the fat cells and make the fat cells get big, and that causes insulin resistance. So you may wonder, is it common for people to have high insulin levels? If high insulin is a main problem with insulin resistance, is it actually even that common? It is very common. If a person just eats 3 meals a day, then it's not so bad, because then you could see that insulin is up and then it comes down, and then they have substantial periods of time when insulin is low. However, most people snack all the time, so their insulin levels are elevated all the time. This is where insulin wants to be, at a low level, but they never give it time to come down, because right when insulin is coming down, for example, after eating breakfast, insulin goes back up because they have a snack. And then they eat lunch and it goes back up. And then right when it's starting to come down, they bump it back up with a mid-afternoon snack, and then a big supper, and then an evening snack. And so every person is, every waking moment, every moment of the day is spent with high insulin levels. And this can be even worse. If a person is insulin resistant, then the insulin never comes down, and it's high all the time, driving insulin resistance and making fat cells get bigger and bigger and bigger. So what is the best way to shrink fat cells? We want to shrink our fat cells. We need to lower insulin. We need to give the body a break from having high insulin levels all of the time. There are two things. When your friend asks you, how can I lower my insulin to shrink my fat cells and improve my insulin sensitivity? You say there are two things you can do. You say, friend, two things. And they say, what are those two things? You say the first one is control carbohydrates in your diet. And then the second thing you say is frequently fast. Give your body a break from eating and drinking food all the time. But you may wonder, your friend may ask you, why focus on carbohydrates? These are the three main parts of the human diet: fats, proteins, and carbohydrates. Worldwide, 71% of all calories, so 71% of everything a person eats, is coming from carbohydrate. So the vast, vast majority of the foods we eat come from carbohydrates. But is that a problem? It is a problem if you are worried about high insulin levels, because this is what happens to insulin levels when we eat. Fat, we have no effect. Protein, we have maybe a very small effect, if any. When we eat carbohydrates, even for an insulin-sensitive person who can handle carbohydrates, still carbohydrates go up about 20 times and takes about 3 hours to come down. But if an insulin-resistant person eats that same carbohydrate, their insulin levels will go higher and take even longer to come down. And even a healthy person who eats a lot of carbohydrates, like a couple bowls of rice, then their insulin can be elevated for over 10 hours. And if we eat too much carbohydrate for just 1 week, insulin levels can go up by 2.5 times. So this is why we tell our friends, number one, control carbohydrates. Now they're going to ask you, how? How can I control the carbohydrates that I eat? You say the first thing you can do, friend, is focus on fiber. Make sure that anytime you are eating carbohydrate, that you are also eating fiber. When we eat carbohydrate, like I showed you earlier, this is what happens to insulin. But if your friend has balance when they eat their carbohydrate, then it can bring down the insulin effect by about 20%. In fact, we did a little study with Unicity. In the past, and I want you to remember this, in the past, we would tell people, take balance 15 minutes before your meal. And it helps. It does bring it down. It's a good level. That's a good glucose. However, if you take balance with the meal, then it brings it down even more. That's what we show here. That if you take balance with the meal rather than 15 minutes before, it works even better. So make sure that you teach your friend this. Now, we focus on fiber, and that helps bring down insulin, but also you can tell your friend may say, well, how else? How else can I help control carbs? You say chlorogenic acid. Chlorogenic acid also helps control the glucose and the insulin after you eat carbohydrate. Here is the results of a study where they found that not only do chlorogenic acid help bring down glucose and insulin after eating carbohydrate, but also at any moment, they found that glucose levels are better controlled, are lower. So the blood glucose is down, that helps the insulin come down. Because if glucose goes up, insulin wants to go up. And then insulin wants to push the glucose down. But if glucose is already down, then insulin can be down as well. Now your friend may ask you, and they say, well, how can I get chlorogenic acid? Where does that come from? You say, I have something that can help. Because Unimate is enriched. It has been made to have lots of chlorogenic acid in it to help bring down glucose and insulin. So these are two good ways. When your friend says, how can I control carbohydrates? You say, I have two things that can help you control carbohydrates and feel great. Now, number two, you tell your friend, we eat too much. We always are eating and increasing our insulin. We need to fast. Now, this is very much a part of culture through the Middle East. Fasting is looked at as a very good thing. I believe it is very, very good for the body. It's very good for the spirit. It helps us be in control. Now, at a minimum, we would say at least do mini fasts. Just don't eat between your meals. Have breakfast and then don't eat for 4 hours. Lunch, don't eat for 4 hours, at least. But eventually your friend will be ready for a little more. And now you can say, let's cut out a meal. Let's cut out breakfast or let's cut out supper. Breakfast is the easiest to cut out. But even still, your friend may say, but when I have even a small fast, I get so hungry. How can I reduce my hunger? You say, I have something that can help you. And then you show them the Unimate again, and you tell them, Unimate, we have designed this to have lots of theobromine. Theobromine is the part of Unimate that tastes a little bitter on our tongue. We take it and we taste a little something unique. It's a little bitter. Theobromine is a bitter tastant, we say in English. It just tastes bitter. When the brain and the gut, our intestines, taste something bitter, it actually tells the brain that we do not need to eat. So if your friend says, well, Unimate has a little bitter taste, you say, exactly. That's on purpose, because the bitter taste helps the brain tell the gut that we don't need to eat as much. And so appetite will go down, and it makes fasting easier. Also, you tell your friend that when they take balance, the microbiome or the bacteria within our intestines, they will eat the fiber in balance. And when they eat the fiber, they turn it into short-chain fatty acids, small little fats that we don't taste, but our bacteria do. And it moves into our bloodstream. And when short-chain fatty acids come into our bloodstream, it has a very strong effect on appetite. It signals to the brain, the short-chain fats that our bacteria are making from the fibers in balance, signals to the brain that we don't need to eat. It helps control hunger. Now, I want to transition into talk a little bit about hormones that we make in our gut. Our intestines make many, many hormones, but the most famous hormone that our intestines make is a hormone called GLP-1. And GLP-1 does a lot of very good things for our body. It helps slow down our intestines. So when we eat food, we feel full faster and longer, so that helps us eat less. It also stimulates our fat cells to burn more fat. And GLP-1, this hormone that comes from our guts, will go to our brain. And it will tell our brain, it will say, brain, you don't need to eat. You are already full. So GLP-1 really helps the body burn more fat and it helps the body eat less. And that's a very good combination to help shrink fat cells. In fact, GLP-1 works so well that there are certain drugs like Wegovy and Ozempic that have been made to just take advantage, to turn up the GLP-1 activity in the body. I wonder, have you heard of these drugs before? Have you heard of Wegovy and Ozempic? I bet that most of you have. They have become very, very popular. Now, I want you to know how it works. I want to teach you how these drugs work, because then you can answer questions for your friend, and then you can give them a better option. Firstly, GLP-1 drugs work by inhibiting a hormone called glucagon. And glucagon is the opposite to insulin. Insulin will, when insulin goes up, it wants to bring down glucose level. When glucagon goes up, it wants to increase glucose levels. But what happens is that GLP-1 inhibits glucagon, and glucagon will tell the liver to release lots of glucose. But if GLP-1 has inhibited a glucagon, then there's less glucose coming out of the liver. And so blood glucose levels go down. That helps control blood sugar, which helps control insulin. Also, as I shared with you earlier, GLP-1 will slow the stomach. It will slow the intestines down, so food stays in longer. That will reduce hunger. Now, here's a problem, and you teach your friends this. You say, sometimes Wegovy and Ozempic can slow the stomach down too much. And there are some people, as reported in this science publication, who have their intestines start to freeze. They are paralyzed and they stop working. That can be a very, very dangerous scenario. So there's a problem with these drugs where it slows the intestines down too much. Also, when we slow the intestines down too much, we don't absorb food as well, and the body starts to become malnourished. It's not healthy. And this study found that when people lose weight with these drugs, Wegovy and Ozempic, up to 40% of the weight that they lose is coming from their muscles and their bone. That is a substantial amount of weight loss that is coming from a healthy tissue. That when we lose weight, we want it to come from our fat tissue. So what this study found, that for every 10 kilograms of weight that they lose, 6 comes from fat and 4 comes from muscle and bone. That is a lot of lean mass to lose. This is important because look what happens when people get off the drugs. When they start the drug, they lose lots of weight. That's this line here. And then when they stop the drug, immediately they gain weight back. But what kind of weight do they gain back? Remember, the body, as I just said, they can lose fat mass and they can lose lean mass, muscle and bone. They lose both. When they stop taking the drug, one of them comes back very quickly. The other does not. And so the fat mass, this gain, when they're losing this, 60% is from fat, 40% is from lean mass. When they gain it, it's practically all fat mass. And so even though they still weigh 5 kilograms less, about 5 kilograms less, they actually can be fatter than what they were before, because they lose muscle and fat and they gain only fat. This is important because in the UK, or this is a publication in the UK, but another publication in the US finds that about 70% of people who go on these drugs, the GLP-1 drugs, they get off of them in 2 years because they feel sick all the time. They get sick of feeling sick. They don't want to feel sick in their stomach anymore. And so they choose to get off of them. And then they gain all of the weight back and possibly end up even fatter than before they ever started the drug. So you may hear your friend ask about these drugs. And then they may ask you, well, if these drugs have so many problems, how can I get the benefit of the drug without all of these negative problems? Then you say you need to make more of your own GLP-1. So remember, we make GLP-1. Our intestines make this as a hormone all the time. We tell our friend, let's make more of our own GLP-1, and here's how you can help them. You say, I have 2 things that can help you. And they say, again, more balance in Unimate? And you say, yes, let me tell you how. First, Unimate has many molecules. I already mentioned the chlorogenic acid, also EGCG, also ferulic acid. All of these are different molecules, but the one thing they have in common is that when they come into your intestines, they will tell your intestines to make more GLP-1. And we saw this. We studied the blood after taking lots of Unimate, and we found that GLP-1 levels were up about 60%, a significant increase in GLP-1 from the group not taking Unimate. And we published some of these results, and I just want to share a little bit with you. This was a manuscript that we published from my lab using Unimate. And we looked at metabolism in fat cells and metabolism in muscle cells. And in fat cells, we found that with Unimate, that the fat cells were wasting energy, that it was burning energy faster, higher, which can help with shrinking fat cells. Also, at the muscle, we found that the muscle was better at using energy, that it was more efficient at using energy, making more energy for the muscle to work. So it helps the muscle work better, and it helps the fat cells burn more fat. That's a very, very good effect. But also remember that we also found more GLP-1, because that was the main thing I wanted you to understand. Now, also, lastly, your friend may say, well, what about balance? Does that help with GLP-1? Yes, it does. This study that was published finds that the fibers in balance activate the L cells. And the L cells are the cells in the intestines that make GLP-1. So once again, we have another way of making GLP-1. So you tell your friend that insulin resistance is the most common problem in the world, and that the most common cause is when fat cells get too big because insulin is too high. Then they say, well, how can I control my insulin? And you say you control carbohydrates, you fast more frequently. And we have two very good ways to help them do it, because it can be hard. It can be difficult to do because you're asking your friend to change the way they eat. Well, they don't have to change too much. By just including the feel great system, it will help them start to have significant metabolic improvements. I hope that this information has been helpful. I hope that you feel like you can now go and teach your friends. Now it's time for you to be the professor and let your friends be the student. And as Majdi said, if there's time for some questions, I think we have time. I would be happy to try to answer questions.